Hello, everyone. I'm Maria Milan, the President and CEO of CIRM. Thank you for joining us for this amazing day. This morning, you've heard from researchers, scientists, and patient advocates. They've been called all-stars, and they have proven why. Now, I'm so excited to introduce our keynote speaker, Dr. Nadine Burke Harris, California's first ever Surgeon General. Dr. Burke Harris has revolutionized how we look at healthcare. She is known for linking adverse childhood experiences and toxic stress with harmful effects to health in childhood as well as later on in life. Dr. Burke Harris received her undergraduate degree in integrative biology from UC Berkeley, her medical degree from UC Davis, and after earning her master's degree in public health from the Harvard Chan School of Public Health, she went on to a residency at Stanford in pediatrics, and I believe we actually crossed each other in the halls and in the ICU during that time. As an insightful and extremely aware physician, Dr. Burke Harris was struck by the emerging research of the impact of early traumatic experiences on present and future health and pursued this to strive for better healthcare approaches for our patients. From 2010 to 2012, Dr. Burke Harris was at the California Pacific Medical Center, where she also co-founded the Adverse Childhood Experiences Project in the Bayview Hunters Point neighborhood in San Francisco. And following this, an offshoot was the Center for Youth Wellness, which was created in 2012 to create a model and multidisciplinary approach that focuses on preventing and treating toxic physiologic and neurodevelopmental results of adverse childhood experiences. Her 2014 TED Med talk in San Francisco called How Childhood Trauma Affects Health Across a Lifetime has reached over 7.2 million views. And for those who haven't seen it, I would highly recommend watching that TED talk. Dr. Harris released her book, The Deepest Well, Healing the Long-Term Effects of Childhood Adversity, just recently. On January 2019, Governor Gavin Newsom appointed Dr. Burke Harris as the state's first Surgeon General. She currently serves as a government liaison for the American Academy of Pediatrics National Advisory Board for Screening and sat on the board of the Committee on Applying Neurobiological and Socio-Behavioral Sciences from prenatal through early childhood development, a health equity approach for the National Academy of Medicine. Dr. Burke Harris is a recipient of multiple awards, including the Arnold P. Gold Foundation Humanism in Medicine Award, presented by the American Academy of Pediatrics, and the Heinz Award for the Human Condition. She was named one of 2018's most influential women in business by the San Francisco Business Times. This is just a fraction of Dr. Burke Harris's accomplishments. We are so honored and excited that Dr. Burke Harris can join us for this very special CIRM Grantee event. Please join me in a warm welcome to our Surgeon General, Dr. Nadine Burke Harris.
Thank you so much, Maria. That was a very generous introduction. And I'm so thrilled to have the opportunity to chat with you and CIRM grantees today about adverse childhood experiences and toxic stress, and more importantly, how we utilize the science to improve health in California. So I will start by just popping up my presentation. So for those who are not familiar with adverse childhood experiences and toxic stress, I'll start with a brief introduction and then dive into my favorite part, which is the science. So when we're thinking about the purpose for which we apply science, right, it's to improve health, it's to improve health outcomes. And in early 2019, when I was sworn in as California's first Surgeon General, there were three real areas of focus that the governor and I agreed on in terms of areas where I would do a deep dive to tackle. And those include health equity, early childhood, and this issue of adverse childhood experiences and toxic stress. And for those who are unfamiliar, or just as a refresher, even for those who are, the term adverse childhood experiences really came from a landmark study that was conducted by the CDC and Kaiser Permanente in 1997. And in that study, they asked 17,500 adults about their history of 10 categories of adverse childhood experiences. And these include physical, emotional, or sexual abuse, physical or emotional neglect, or growing up in a household where a parent was substance dependent, mentally ill, incarcerated, where there was parental separation or divorce, or intimate partner violence. And what they found in this landmark study were two things that were really game-changing. The first was that adverse childhood experiences are incredibly common. So in that study, 2/3 of participants had experienced at least one ACE, and 1 in 8 folks had experienced 4 or more. Since then, the state of California has actually started tracking this information in a systematic way as part of our behavioral risk factor surveillance data that we report to the CDC. And statewide, 62% of Californians have experienced at least one ACE, and 16% have experienced 4 or more ACEs. And we see that this prevalence is actually very similar across racial and ethnic groups. We see that looking at national CDC data, we see some slight increases in ACE prevalence among African Americans, Latinos, and also American Indians and Alaska Natives. But overall, what we take away, right, is that ACEs happen everywhere. They happen with every racial and ethnic group. They happen at every income level, although we do know that some populations have greater exposure and therefore greater risk. Now, the other thing that they found, in addition to the fact that adverse childhood experiences are incredibly common, was that there was a dose-response relationship between adverse childhood experiences and negative outcomes. And for many of us, right, and for some outcomes, that was kind of intuitive. It was really consistent with what we expect, especially when we think about for mental health. So when we see mood disorders, anxiety disorders, substance use, impulse control disorders, we see this dose-response relationship where the more ACEs an individual is exposed to, the greater their risk of having these negative outcomes. Similarly, we see the same for substance use. We see, earlier onset of substance use and typically greater severity in a dose-response relationship. We actually see on a societal level, the same dose-response relationship for homelessness. So this is data actually from Washington State showing, the higher the ACE score, the higher the risk of homelessness. But the thing that was really surprising to many folks was that there was also this same dose-response relationship between adverse childhood experiences and some things that many people hadn't expected before. Things like heart disease, cancer, accidents, chronic lower respiratory disease, stroke, Alzheimer's, diabetes, kidney disease, right? And when we look at the 10 leading causes of death in the United States, having an ACE score of 4 or more is associated with dramatically increased risk for 9 out of 10 of the leading causes of death in the US. And when we look at the cost to the state of California, right? So last year, I and my team published an article that was looking at the cost of ACEs to the state of California from only 8 health conditions, right? So it didn't, for example, it didn't include Alzheimer's. It didn't include, kidney disease, right? But just from 8 health conditions, the annual cost to the state of California was $112.5 billion per year. That's over $1 trillion in 10 years. So we see that adverse childhood experiences not only have a substantial impact in terms of morbidity and mortality, right? But there's also a significant economic impact. But the good news is that ACEs are not destiny, right? And that with early detection and evidence-based intervention, we recognize that we can transform outcomes. But in order to be able to do that, it's critical that we understand the biology of adversity. So we all will recall, right? Like back in the day when, in the early 80s, when patients were coming into the ER and they were having, you know, exceptionally high rates of tuberculosis, right? And as doctors, we patched them up, we sent them out, and we said, tuberculosis, we know how to treat that. And then they would come back, and this time they would have, you know, a rare pneumonia, pneumocystis pneumonia. And we said, okay, pneumocystis, all right, it's less common, I gotta look it up, but I know how to treat it. And we'd patch them up and send them out. And then they came back with Kaposi sarcoma and other maladies. And the real challenge was that these conditions, while they were health conditions that required treating, really they were symptoms of a deeper problem. And until we treat the root cause, we recognize that our patients were going to keep coming back and get sicker and sicker. But when we were actually able to target the root cause, the molecular cause of the problem, right, which was not only a virus, but a retrovirus, when we were able to identify antiretrovirals, what we see is that the death rates from HIV/AIDS dropped dramatically. And one of the things I love about this slide is that this line up top in blue, that's the death rate for African-American males. This next line in red is the death rate for Hispanic males. The orange line is African-American females. And I think for many of us, when we are thinking about doing basic science research, clinical and translational research, right? Many folks don't, that's not the first thing that comes to mind when they think about health equity. But when we truly target the root cause and we are able to dramatically improve outcomes, we see the greatest benefit to the communities that are most severely affected. And so when we look at applying the biology of adversity to understanding how adverse childhood experiences lead to all of these different health outcomes, right? It works a little something like this. So imagine you're walking in a forest and you see this guy, right? What happens in our brains and bodies? Well, immediately our amygdala, right, the brain's fear response, sounds the alarm, right, and activates our fight or flight response. So we release a ton of stress hormones, including adrenaline and cortisol. You know, we have a corticotropic releasing hormone, CRH, kicks off the party, and we have all these activation of these stress hormones. And so our hearts start to pound, our pupils dilate, our airways open up. And we shunt blood, right, to our large muscles for running and jumping so that we can either fight the bear or run from the bear, right? That's the activation of our fight or flight response. Now, the problem is, if you were to think about it, fighting a bear wouldn't seem like a good idea, would it? No, he's big, he's got teeth, look at him, he's got claws. And that's why the amygdala actually sends projections to the prefrontal cortex, this part of the brain that's responsible for judgment and impulse control and executive function. And it turns it way, way down, right? We see this dramatic downregulation of prefrontal cortical functioning, right? Because if you're in a forest and there's a bear, the last thing that you want is impulse control getting in the way of survival, right? And instead what it does is it turns up the noradrenergic nucleus of the locus ceruleus, or as I like to call it, the part of the brain responsible for, I don't know karate, but I do know crazy, right? This is the within the brain stress response center, and it gets us amped up. Now, the less commonly known thing when we activate our stress response is that it also activates our immune response. Because if you're getting in a fight with this guy, you want your immune system to be primed to bring inflammation to stabilize whatever wounds so that you can live long enough to either beat the bear or get away. It's brilliant. It was evolved over millennia to save our lives from a mortal threat. But the problem is what happens when this bear comes home every night. And this biological, this physiological response is activated over and over and over again. And it goes from being adaptive or life-saving to maladaptive or health damaging. And children are especially sensitive to this repeated activation of the stress response, right? Because we recognize this period of early childhood development is a time of critical and sensitive periods of neuronal plasticity. And so high doses of adversity during these critical and sensitive periods leads to outsized impact in the development of children's brains and bodies. And so high doses of adversity in childhood is associated with dysregulation of the biological stress response, right? The sympathoadrenomedullary axis and the hypothalamic pituitary adrenal axis, our SAM and HPA axes. And what we see is they can become overactive and have difficulty turning themselves off, right? So we lose feedback inhibition of the physiologic stress response. We see overactivation of the amygdala, and in fact, we can see structural and functional changes in the amygdala. We see inhibition of the prefrontal cortex, which results in impaired executive functioning. We see toxicity of the hippocampus, right? So high doses of cortisol is neurotoxic to hippocampal neuronal cells. And that leads clinically to difficulty with learning and memory. We see changes to the ventral tegmental area of the brain and the reward center, the nucleus accumbens, right? Which is associated with altered reward signaling and increased risk of engaging in risky behaviors. So we saw previously increased risk of substance dependence, et cetera. But immunologically, we also see increased inflammatory mediators and markers of inflammation and inhibition of anti-inflammatory pathways, which lead to increased risk of viral infection, certain bacterial infections, and chronic inflammation. On the hormonal level, we see long-term changes in ACTH, adrenal corticotropic hormone, cortisol, adrenaline, and other hormones that lead to increased stress activation in the body. We see changes in growth hormone, thyroid hormone, pubertal hormones that can lead to changes in growth and development, as well as metabolism and puberty. We see changes in leptin and ghrelin, which are hormones associated with appetite and satiety that lead to increased risk of overweight and obesity. And ultimately, when we think about it, right, like if you're exposed to early adversity, we get it. But once you're a grown-up, right, like once you're old enough to leave the house, why do we see these long-term changes in health risks, right? Increased risk of cardiovascular disease, increased risk of stroke. Well, what we see is that changes in the way our DNA is read and expressed, right? Changes in epigenetic regulation, alterations in DNA methylation and histone modification lead to changes in the way our brain and our organ systems subsequently respond to stress. It leads to changes in the way they're wired to respond to stress. And finally, we see erosion of our telomeres, right? Those bumpers on the ends of our DNA that protect our cells from wear and tear leads to premature cell death and altered cell replication, increasing risk of disease. And so we now understand that when we see this early life adversity that is influenced by protective factors as well as predisposed vulnerability, this leads to long-term changes in neuroendocrine, immune, and genetic regulatory functioning, right? That then has clinical implications in terms of increased risk for endocrine, metabolic, reproductive, and lots of different physiologic derangements and increased risk of negative health outcomes. And one of the things that was a real question that people asked was, wait a minute, so if you have early adversity, why are there, you know, you're telling me that it's, you know, double the risk of ischemic heart disease, 3 times the risk of chronic lung disease, 2.5 times the risk of stroke. But we now understand that this toxic stress mechanism, the dysregulation of the stress response, right, is this common pathway by which lots of different types of early adversities, whether it's abuse or neglect or having a parent who's mentally ill, right? That leads to a common pathway of dysregulation of the stress response that then, when you know, buffered by protective factors or through mechanisms of predisposed vulnerability, can lead to a range of physiologic outcomes. And so we see that although the original ACE study was done in adults and really looked at adult health outcomes, including those 9 out of 10 leading causes of death, which I showed earlier, we recognize that the signs and symptoms of toxic stress are evident as early as infancy, right? So in babies, we see, you know, developmental delay, growth delay, failure to thrive, sleep disruption. In school-age kids, we can start to see increased risk of asthma, pneumonia, viral infection, atopic disease, learning and behavior difficulties. And then in adolescence, we see more increased risk of obesity, diabetes, headache, abdominal pain, and then substance use, teen pregnancy, pubertal changes, hyperthyroidism, etc. And one of the things that we recognize is that this toxic stress physiology can in fact be handed down from generation to generation through this epigenetic, some of these epigenetic and stress signaling pathways, right? And so mom's own history of ACEs, the adversities that a mom experiences in pre-pregnancy, right, before she's 18, actually affects her risk of perinatal and pregnancy outcomes, from preeclampsia to impaired fertility, altered microbiome, affecting pregnancy intention, maternal risk behaviors, maternal chronic diseases like diabetes and obesity, and increases the risk for fetal loss, preterm birth, and low birth weight. So now that we understand the mechanism, we understand the biology, right? The thing that I get so excited about is that we have the opportunity to use the science to break the cycle. So how do we do that? Well, first, one of the things that's critically important is recognizing risk factors for toxic stress, right? That while adverse childhood experiences are risk factors for toxic stress, other risk factors for toxic stress also exist, right? ACEs are not the only risk factors for toxic stress. So things like racism and discrimination also can lead to a dysregulated stress response, poverty. And now we're recognizing that the pandemic is not only increasing ACEs, but it's also reducing the buffering factors that can reduce the impact of those ACEs, therefore increasing the risk of developing the toxic stress response. Because when we look at the definition of the toxic stress response, as initially elaborated from the National Scientific Council on the Developing Child, and most recently just updated by the National Academies of Sciences, Engineering, and Medicine, we recognize that it happens on a spectrum, right? So our stress response is characterized into the positive stress response, the tolerable stress response, and the toxic stress response. And the positive stress response is that normal and healthy response to an immediate stressor. It involves brief activation of the stress response with brief elevations in heart rate, blood pressure, and hormonal levels. But homeostasis, right, the body's biological balance, recovers quickly through our natural coping mechanism. The tolerable stress response is the adaptive response to a more severe or intense, but time-limited stressor. And with the tolerable stress response, homeostasis can recover through the buffering effect of caring adults and other interventions, right? But it's when we don't have those buffering effects and when the stressor is not time limited that we see prolonged allostasis, right? The change in the biological baseline that establishes the chronic stress response, where we see changes in brain architecture, we see changes in the structure and function of the brain and developing organ systems in a way that increases the risk for morbidity and early mortality. So when we understand that, right, if we dive a little bit more deeply into what is it about? So I'm just going to go back for a second. Like, it's really clear. In fact, the National Academies of Sciences, Engineering, and Medicine just issued a whole consensus report about this in 2019, right? About the powerful effect of the buffering, caregiving, and other interventions to mitigate the toxic stress response. So what is it, right? As we dive a little deeper, because again, when we understand the mechanism, then we have opportunities to deploy this science in service of healing patients who are experiencing a toxic stress response. So one of the things that we know about supportive relationships, right? It works on several different levels. It works on the psychological and developmental levels in terms of safety signals and positive relationships. But it also activates through a series of pathways, including oxytocin release, affecting oxytocin receptor distribution and binding. It affects neural priming in the ventromedial prefrontal cortex. And also, it's believed that there are other possible mediators, including dopamine, serotonin, opioids, epinephrine, and norepinephrine, in terms of how the social buffering works. And what we do recognize is that social buffering actually has a direct effect in inhibiting the biological stress response through HPA and SAM activation. And so when we look at how this all works together, right, we understand that responsive caregiving and supportive buffering not only affects our neurological systems and our neurological priming, but it also affects our immune system, our cytokine balance, our inflammatory tone, and the maturation and proliferation of our T cells. And all of this happens, you know, in the biological environment where we have our brain development, our immune system, our neuroendocrine responses are all developing and adapting either in a context of adversity, trauma, activation, or in a context of buffering and regulation and moving towards homeostasis. And that profoundly affects our risk of subsequent morbidity, mortality, and in addition, social and behavioral outcomes. So when we understanding this, right? Understanding this, one of the things that I think is really powerful is the ability to take this science from animal studies, from you know, some of the basic science research on understanding how the stress response works, how it affects behavior development and physiologic functioning, and really start looking at, okay, so how does that affect patient care? How do we use this science to improve outcomes for the 62% of Californians who have experienced at least one ACE? And what we see is that this buffering of the physiologic stress response actually is associated with clinical improvement of outcomes, right? So an MRI studies found that institutionalized children who were randomized to high quality nurturant caregiving, right? And I'm not going to talk about how sad it is that kids need to be randomized into high quality nurturant caregiving. But in this particular study, they did MRI, brain MRIs of kids at age 2 when they were randomized, and then subsequently at age 8. And what they found was that the children who were previously institutionalized, who were randomized into high quality nurturant caregiving, the developmental trajectory of the white matter structures of their brains at age 8 looked like the brains of children who were never institutionalized, and were significantly differentiated from the kids who were in the care as usual group. So what that indicated was really normalization of the developmental trajectory of those white matter structures. Similarly, we see that interventions like meditation, which helps to regulate the sympathetic and parasympathetic balance, right, of the stress response, is associated with decreased interferon gamma, natural killer cell production of interleukin 10, and increased T cell production of IL-4. And that social supports protected against the rise in infection risk associated with the increased frequency of conflict. We see oxytocin, right? That bonding hormone, one of my faves, released during childbirth. And I have to say, as a mom with 4 boys, every time, one of my boys gets into a scrape or something scary or stressful happens, the first thing that I do is scoop them up and wrap them up into a hug, right? And what am I doing? Well, not just letting them feel safe and empathized with, but I'm also releasing oxytocin in their bodies, right? And we see that oxytocin is associated with inhibiting the stress response, enhancing bonding, protecting against stress-induced cell death, has anti-inflammatory effects. It enhances metabolic homeostasis and protects the vascular endothelium, right? So all of the kind of the opposite of everything that the toxic stress response does, oxytocin seems to be an important part of regulating or reestablishing that homeostasis, and really has the contradictory effects. Research from McGill University found that nurturant caregiving, again, was also associated with epigenetic changes. So they actually did, now a very famous study in rats, and they had rat pups. And a little while after the rat pup was born, they'd had a research assistant go in and handle them and stress them out. And what they found was that some of the rat moms did lots of nurturant caregiving, lots of licking and grooming and nursing, and some rat moms not so much. And the rat pups that received lots of nurturant caregiving, when they got older and they had tests of how intrepid they were, their stress tolerance, their ability to navigate a maze, so some of their cognitive and executive functioning tests, and they performed better on these tests, right? They actually looked at the feedback inhibition of their biological stress response of their HPA axis and found that their HPA axis actually turned itself off, had more normal feedback inhibition. And what they found was that this was strongly associated with the epigenetic markers that were associated with the nurturant care. And then the fascinating thing that they did, and I will say, I think that maybe Michael Meany and his colleagues have been watching too much Lifetime television, but they switched those rat pups at birth, right? And what they found was that for the pups that were raised, the pups that were the biological offspring of rat moms that did not do lots of nurturant caregiving, but they were raised by a foster mom who did lots of nurturant caregiving, they performed better on these tests of executive functioning. They had a more normally functioning HPA axis with more normal feedback inhibition. And when they looked at their epigenetic regulation, It was the markers of their rearing mothers, not of their biological mothers. So we really, that was a really powerful example of how nurturant caregiving can be associated with epigenetic changes. And so when we look at this research, in animal studies, in vitro studies, clinical studies, but when we look, then translate that to population-based studies, right? And we look in populations around the presence of these buffering factors, right? What we see is that even for those who have high ACEs, right, the presence of all of the buffering care assets, and they looked at a bunch of them, including having a trusted adult and a number of these buffering caregiving factors that help to reduce the stress response. They also found that it reduced the prevalence of total childhood poor health, including asthma, allergies, headaches, digestive disorders, and school absenteeism from 59.8% to 21.3%. And so as we start to understand, how do we go from the molecular, right, the understanding the disruption to the physiologic stress response, to the physiologic, to the clinical, to the societal, right? I believe we have a powerful ability to translate this science to improve the health of our population. And as California's first Surgeon General, I have set a bold agenda to cut ACEs and toxic stress in half in a generation. Now, that sounds incredibly ambitious. However, it's not pie in the sky. It's based on things that we've actually been able to do before using a public health framework. So for example, when we look in the United States between 1996 and 2016, right, 20 years, that's one generation, we cut the prevalence of teen smoking from 25% to 3.6%. And we did that in 20 years. An even better example, here in California, we implemented a unique initiative targeting maternal mortality. And with this initiative, the California Maternal Quality Care Collaborative, through systematic efforts to determine the sources of maternal mortality and establish protocols to train our providers on how to respond in a uniform and evidence-based way, we reduced maternal mortality in the state of California by 55%, while maternal mortality continued to rise, right? This is red line here, continued to rise nationally. We did that between 2006 and 2013. And so when we look at how we can cut ACEs and toxic stress in half in a generation, right, it requires us to take an evidence-based approach. And step one is intervening early, taking advantage of the fact that biologically, a number of critical systems are developing and humans have high plasticity during these early life stages. So intervening early was an important recommendation of the National Academy of Sciences, Engineering, and Medicine. And so California's approach has been really to take a collaborative approach to primary, secondary, and tertiary prevention. Primary prevention includes addressing the systemic and structural factors and raising public awareness, systematically deploying broad-scale screening to enable early detection, right? That's secondary prevention, detecting earlier so that we can intervene earlier when it's less costly and more likely to be effective. Interrupting vertical transmission, that transmission from parent to child, by advancing ACE screening not only in children, but also in adults, with a special focus on the prenatal and early parenting years. Coordinating and strengthening our network of referral and treatment systems, right? That's the tertiary prevention. What is our treatment and intervention? To make them more effective, accountable, and easy to navigate for children and adults. And finally, which is, I'm going to say is my, perhaps my favorite part, advancing the science of toxic stress to identify potential therapeutic targets and improve the efficacy of our interventions. So when we look at how this all fits together into a public health approach, when we look at, public awareness, cross-sector training and competency, county and local network of care coordination, trauma-informed clinical care, primary care screening for ACEs, and toxic stress research. Currently, the Office of the Surgeon General is working hard to advance efforts on all of these fronts. But if there's one thing I would say, there's a way in which this pyramid should really be flipped, right? Because we know that all of this work really is based on the research. It's based on the rigor and fidelity of the research in order to put in place these interventions. And so California's investment that is really based on the science and this evidence includes almost $150 million over 2 years to not only train providers on how to screen for adverse childhood experiences, how to recognize the signs and symptoms of toxic stress, and how to respond with trauma-informed care, but also for once, this is not an unfunded mandate. We're actually reimbursing our Medicaid providers for screening for ACEs. So any Medicaid provider who goes through the training, because just like anything else in healthcare, while we want our providers to screen, we want to make sure that they're appropriately trained on how to screen and how to respond. But in addition, we initiated, in partnership with the California Initiative to Advance Precision Medicine, we've issued a $9 million RFP for demonstration projects that use a precision medicine approach to address the health impacts of adverse childhood experiences and toxic stress. And finally, really doing that cross-sector collaboration and coordination across the Newsom administration to make sure that all of our efforts really tie into each other. And so our initiative is called the ACEs Aware Initiative, focused on empowering clinicians and providers with training and tools. We're doing a phased approach, which includes provider training, provider engagement, and then also a learning and quality improvement collaborative so that we can really implement a data-driven, iterative evaluation and quality improvement process so that we can identify and disseminate best clinical practices. So right now, the way that our initiative is structured and the way that our current screening tools and trainings and response is structured is that we're training providers on how to implement principles of trauma-informed care, how to identify ACE-associated health conditions. And on our ACEs Aware website, we have a long list of ACE-associated health conditions, both for adults and for children, which have the odds ratio of these health outcomes for individuals who have 4 or more ACEs. And then recognize that we recommend the current evidence, that we supplement treatment of these ACE-associated health conditions with interventions that specifically target an overactive stress response. And some of those include things like mindfulness, meditation, social supports, mental health interventions. But one of the things that I think is really important, right, is that when we understand the science, the opportunity to advance the research so that we can potentially supplement current best practices with supra-physiologic interventions to regulate the stress response, I think is an extremely promising area of research, right? I think many folks have, when we thought about the effect of early adversity and thinking about what our interventions are, we recognized that much of the research that has come into this field has appropriately come from our mental and behavioral colleagues who have been shouting from the rooftops about the impact of early adversity on health. But now that we understand the dysregulation of the immune system, the overactivity and the dysregulation of the HPA and SAM axes, now that we understand the role of oxytocin in regulating the stress response as well as other factors, right? The opportunity to use this science to develop novel therapeutics, I think, is really powerful. And particularly considering the fact that we're talking about almost 17% of Californians have 4 or more adverse childhood experiences to a cost of hundreds of billions of dollars per year just in the state of California alone. And so the opportunity to improve outcomes for patients and also improve health equity and health outcomes, I believe, is a very powerful one. And so as we apply the current best practices, you know, validation of strengths and protective factors, referring patients to current best practices, including mental health, social work, so that we can reduce that dose of adversity. We also recognize that we have a lot more science to do in this area. And so we certainly need more researchers across the state, across the country, really looking at how do we exploit these mechanisms, the physiologic mechanisms of repair to improve outcomes for individuals who have experienced adverse childhood experiences or toxic stress. And finally, the National Academies of Sciences, Engineering, and Medicine recommends conducting research that measures the impact of chronic stress on all relevant organ systems and determines the specific molecular and biological pathways of interaction, both during the prenatal and postnatal, but also developmental, and I would say over the life course, right, that are directly relevant to potential intervention and particularly to address health disparities. So coming up later this fall, my office will be releasing the Surgeon General's report on adverse childhood experiences and toxic stress, because I believe that with all hands on deck, as we are, you know, harnessing and galvanizing the time and talents of our primary care providers, our community partners, but also our mental and behavioral health partners, our cross-sector partners, and also our research partners, right? As we're advancing the science, I believe that when it comes to the issue of adverse childhood experiences and toxic stress, we have the opportunity to see this dramatic reduction, right, over the next 2 decades in a generation, just as we saw with cigarette use, just as we saw with maternal mortality, just as we saw with HIV/AIDS, right? Every single one of us has an important role to play in shifting the curve, in improving outcomes and creating breakthrough solutions for our communities and for Californians. Thank you so much, and I will take the opportunity to answer some questions.
Thank you so much, Dr. Burke Harris. That was an incredible keynote talk and a tour de force. And we are really very, very fortunate to have you at the helm with your understanding of medicine, science, and behavior and social sciences. It's quite an amazing intersection of all of those interests and skill sets that's going to help drive this. And we're really looking forward to that report in the fall. We have a few questions. Some of them were coming in during your talk, and maybe this is another opportunity to kind of bring up some things that you already may have addressed, but it'd be great to if we could just go through these questions. So the first question is, how can we as Californians address the ACEs cycle? And how can the scientists doing the work that they're already doing, whether it be discovery, translational, clinical stage, already start thinking about how they can, craft their research plans according to this, taking this into account, even today?
Yeah, so the funny thing about being the Surgeon General is that a big part of my job, particularly in leading our efforts around ACEs and toxic stress, is really helping folks to recognize the role that they are already playing and how that can coordinate with the larger efforts, right? So if you are a researcher, be a researcher, right? I was recently, so as part, in my role, I'm also on the governor's task force on Alzheimer's. And I was recently talking with researchers who are doing Alzheimer's research and specifically looking at the fact that individuals who have had greater doses of adversity, or particularly certain communities, seem to have poorer outcomes when it related to Alzheimer's. So within whatever your sphere of research is, understanding to the extent that it's consistent with your research focus, I think one of the questions is interrogating those questions about why is it? What are some of the molecular mechanisms that underlie some of these patterns that we're seeing with poorer outcomes for individuals who have experienced greater doses of adversity? And if whether you're looking at that in a basic science model, or an animal model, or even looking at cell signaling, what is the role of high doses of adrenaline and cortisol and CRH in affecting the cell signaling and the functioning of, if you're doing, for example, research in immunology or research in proliferation of neurons, whatever it is, there's a potential connection to the science of toxic stress.
Absolutely, and I encourage the attendees to tune in for the panel later this afternoon called Knowledge Networks, and perhaps we'll hear a little bit more about how genomics data sets from the Precision Medicine Initiative, as well as the CIRM initiative, and our collaborations could be tapped into for this. And so the idea of making sure that we coordinate our efforts, do what we do, but do it well, and be aware of all these resources where we can make those connections, I think is absolutely critical. I love your statement about turning that pyramid upside down, where the science should drive the other pieces, and making sure that this is evidence-based. And I think there's so many opportunities for many of the researchers and stakeholders tuning in today. So that was a very impactful talk. You covered a lot. Thank you so much. I have a second question here that says, it's more kind of on the practice level, on the on the implementation level. Do you see stress evaluation becoming a required part of annual health evaluations, such as blood tests, images, etc., either for healthy, for healthy individuals, or even in the course of treatment of their underlying diseases?
That's a great question. So I'll tell you what I envision. So in my previous life, before I became State Surgeon General, one of my roles was as founder and principal investigator of the Bay Area Research Consortium on Toxic Stress and Health. And we did a randomized controlled trial looking at ACE screening, and then also looking at biomarkers for toxic stress, right? Because one of the biggest challenges that we have right now is that despite everything that I've just shared with you, we don't have agreed upon clinical diagnostic criteria for toxic stress, right? And so right now, the strongest proxy that we have in terms of really having a very rigorous evidentiary basis is the ACE score in terms of cumulative adversity, right? We have very large data sets with hundreds of thousands of folks, internationally heterogeneous population, that say, okay, if you have 4 or more ACEs, your relative risk of ischemic heart disease, is 220%. But one of the things that's really important is a question of, that may be true on a population level, but what does it mean for me? If I walk into my doctor's office and my ACE score is 4, how does my clinician interpret my health risks, based on my physiology, right? My predisposed vulnerability, and then also whatever protective factors I have. And so really understanding, I think biomarkers for toxic stress is really the place, is where we're going in the future, to say it is fast and easy for us to screen everyone for ACEs, right? But for those who do have a high ACE score, right, then how do we do a deeper dive in understanding their physiology and what their actual health risks are? And also the question is, how is that toxic stress showing up in their bodies? Why is it that some patients have severe behavioral outcomes, mental and behavioral outcomes, and the result is primarily neurodevelopmental, right? Whereas some patients develop autoimmune disease, right? Some patients get Crohn's. Some patients develop asthma, right? For a child who has 4 more ACEs, they're twice as likely to have asthma. And so better understanding, is this toxic stress physiology? Is it neurodevelopmental predominant? Is it immunologic predominant? Is it endocrine predominant, right? And better understanding what are the factors that control that? And then what does that mean in terms of our intervention? Right now, all of the tools that we have are very blunt instruments, both for assessing risk and then also for intervention. And what my dream is to see, led by the science and based on the rigor of the science, a better understanding of these pathways in a way that advances our ability to diagnose and treat our patients so that we can get to better outcomes.
Thank you so much. And that would be incredible if we were able to do that, really, truly treat the patients rather than using the blunt instruments. We have, I think, time for 2 more questions. Go ahead, Nadine.
Go ahead. No, I just want to like highlight for folks that recognizing that, I talked a lot about the health outcomes and the 9 out of 10 leading causes of death. But when we are talking about, if we were truly to develop interventions to regulate the physiologic stress response, okay? When we look at our incarcerated population, in juvenile incarceration, upwards of 90% of those kids have ACEs, have at least 1 ACE, 50% with 4 or more ACEs. When we're looking in the special ed population, right? Like when we're talking about the impacts of developing effective interventions for a toxic stress physiology, the impacts, I think, are profound in terms of health outcomes, but in terms of societal outcomes, right? In terms of homelessness and unemployment and, violence and incarceration, I think that there are really far-reaching implications. And that's a big part of the reason why this has been such a big focus for me as Surgeon General, because this truly is a public health crisis. And we have an opportunity to advance the science in a way that could have really, really important implications for our society's future.
Thank you. And then the next question is somewhat related to this, and I'll just read it. I'm fascinated by the relative homogeneity of ACEs across ethnic groups, with the exception of Native Americans. Given what we know about our society, can you comment on how this may be? It goes on, is it possible that there are differing levels of salience across groups and the socioeconomic status impact?
So what the data tells us is that when it comes to the traditional ACEs, while there are differences, and I do want to emphasize that, for example, racism and discrimination are risk factors not only for ACEs, but also for toxic stress, right? There's one way in which they increase the exposures. So for example, if there's racial profiling, right, then African Americans, and we see this all the time, more likely to be stopped by police, and then therefore more systematically more likely, African American children then become systematically more likely to have a parent who's incarcerated. So there's a direct level of increasing ACEs, but there's also a direct mechanism by increasing the risk of toxic stress simply by activating that physiologic stress response, right? And I feel like even I have experienced this as a Black woman. Being Surgeon General doesn't mean that you're immune from that feeling when you get discriminated against, when you have that negative interpersonal reaction, right? And so those repeated experiences of adversity also directly lead to an increased risk of the toxic stress response. But this is why I think that advancing the science and biomarkers of toxic stress is so important, because we know that the original ACEs didn't include discrimination as one of their criteria, right? And so while someone may have a specific a specific number of exposures to the traditional ACEs, we know that the impact of adversity is cumulative. And then if you tack on top of that discrimination, if you tack on top of that other adversities, then we see an even greater risk of toxic stress. And our ability to measure that, I think, is really important. And that's why, looking at biomarkers for toxic stress to better understand how the physiology is playing out and what that means in terms of health risks, I think is really important.
Thank you so much. And we have so many coming in, but we're going to cut it off at this question, which is more of a statement, really. So I want to give you a virtual high five for an amazing talk. And the last question is, do you think in these shelter at home times a virtual hug could result in increased oxytocin levels? Or is it like virtual eye contact, or what can we do to release all that oxytocin?
Yeah. Well, I think that is a question for investigation, right? Of whether there are virtual means to activate that oxytocin pathway, because if there are, they are desperately needed right now.
They are.
So, yeah.
Dr. Harris, thank you so much for joining us. This was an incredible session with you. We really, really appreciate you so generously spending your time, all this knowledge, a lot of information, but done so well. Thank you very much. And we're looking forward to having you over again soon, virtually or otherwise. And I'm sure there will be many people contacting you, because this is such an interesting topic. And thank you for what you do.
Thank you. It's
Bye,
my
everybody.
pleasure.